Hello and welcome back. So today we are going to be talking about conservation of momentum, and these next few videos will most likely help you in doing your quest problems and problems in class. So you can find the PowerPoints for this under Blackboard, under class notes, and this would be the second PowerPoint of momentum. Okay, so let's talk about conservation of momentum. So when do you use momentum? Anytime two objects or more collide, you will use momentum. Anytime two objects explode, you will use momentum. An explosion is just an opposite collision. So collisions go towards each other, explosions go out. You will use momentum. So let's look at this example of a truck hitting a Volvo. Or is it the Volvo hitting the truck? So during the collision, what is the total impulse for the truck-Volvo system? So if you remember, the impulse is just change momentum. An impulse is just the area under a force time graph. So let's, when the truck and Volvo hits force time, the force is going to increase and then decrease with time. If we look at just the average force over time, so if we just average the force over time, so this is F average, we could say the impulse is just the average force over our time. And this equation comes in handy, and you'll see why. Okay. So impulse total is the impulse of the truck plus the impulse of the Volvo. And this is just what we did in our tutorial last class. We used it with blocks C and D and A and M, but it's the same idea. Okay, so if we draw a free body diagram of the truck and a free body diagram of the Volvo, you have the weight and the normal. And you have the Volvo pushing the truck this way, right here. And you have the truck pushing the Volvo the other way. Think for a second. Are these free body diagrams correct? I hope you said no. No, Mrs. Bauer, they're not correct. These two forces, this one and this one, are Newton's third law of pairs, which means that they have to be equal length in opposite directions. So, since the truck pushes the Volvo and the Volvo pushes the truck, they have the same time of impact. So the change in time for the truck and the change in time for the Volvo is the same because they're hitting each other. And since the magnitudes are the same but opposite directions, so one's positive and one's negative, the total impulse of the system, of the truck-Volvo system, is 0. What does this say about the change in momentum of the system? Well, if impulse is the change in momentum, that means the change in momentum is 0. So my promise to you, you always include everything that bumps in your system. The impulse of your system will then be 0. So P initial plus the change in P, which is your impulse, equals your final momentum. But if you include everything that bumps in your system, your final momentum, or your impulse is 0. So that just means your initial equals your final. This is what we mean by conservation of momentum. Momentum is conserved, which means the initial equals the final. Okay, so next video we'll work out a few examples to see what does this mean.